Hello, hello, hello. Welcome back. It is Monday, the 22nd of December, and it is very, very close now to both the TMUA and the ESAT. No evening stream this week because Christmas. But what I'm planning on doing is an evening stream. I'm going to put two more in before the papers, one of which is to go through ESAT in good detail, go through the syllabus, make sure everyone knows what's up and what the question styles are like, and also do a deep dive on the TMUA, really going again through that logic of the paper two in particular, just making sure you've had that explained to you in one place, should you sort of not have seen that before. Now, today, I'm going to continue going through the paper twos, because that's, I think, in my opinion, by far the hardest. I was umming and ahhing. I think I saw somewhere in the comments that someone thought that 2022 was particularly hard. I've already done the paper two on that. So maybe he meant the paper one. So like I might get around to that, but I think it's more important that the paper two stuff gets explained in proper detail. And also then you also get the validation if I sit there really struggling and you're like, okay, yeah, not just me. I think that could be helpful. So I'm going to stick with the paper two. I was also, story time. I was genuinely contemplating. I was like, do I do the paper one? Because I don't know how good my brain's going to be today because I did not sleep well. Well, I say that I didn't sleep long. I slept well. Okay, so here's the story. I have a very, very, very addictive personality, like super addictive personality with specific things. So for me, it's puzzle games. So I was the guy back in 2016 who got like addicted to Candy Crush and made it up to historically significant levels, by which I mean the like 1800s. once they start becoming historically significant years to like a layperson without sort of common knowledge, I was like, okay, maybe this is a bit much. Then I did like wordscapes for ages, and then I got really into cracking the cryptic, like Sudokus, really hardcore rule set Sudokus. Then for some reason, like I get down YouTube rabbit holes. So I had this one where I like found Will Anderson, who does Scrabble, got super into that, started playing Scrabble Go, trying to practice all the little strategies. And then I made the absolute mistake of finding a Settlers of Catan YouTube channel, and then discovered I could play that on my phone. So last night I genuinely just like blasted through about 10 games until about like it hit 11 o'clock and I was like, no, I'll stop now, give myself an hour before bed. And I was like, just one more game. And I did that for like till too late. And I was like, screw it, have a bit of fun, it's Christmas. So I was like, I don't know that I'm gonna be on form for a paper two, but hey, here I know it's good. I'm always like, I'm such a night owl that it doesn't matter how bad my sleep is. I'm like terrible in the morning. Give me a few hours, like by come late afternoon, evening, I'm like completely fine. Which is yet another reason why tutoring is the way forward for me, because then I can work more in like the afternoon, evening rather than the morning. Great going. Now, without much further ado, I've got the papers up and ready to go. So I say we just get into it. We are doing 2019 paper two. And hold on, let me just make sure that the screen share is all working okay. Turning on my little pen tablet. Giving myself a bit of room. All right. 75 minutes on the clock. Now let's see, because my score trajectory has been quite good. I started off on 14, then 15, then 17, then 18, then 18. And I really want to see if I can really pay attention to the fine detail in the wording of the question to get all the marks I deserve. I'm all right being defeated by one, but I hate when I'm like, I should have got that. Just didn't read it right. And it's so easy to do when you're like rushing, trying to get through it in time, or like under exam stress. But like, I'm gonna try. Maybe today is the day when I'm doing it a little bit later in the day. Alrighty then, ready, and let's start the clock. So here, coefficient of the x to the 4 term. Well, that's going to be, we have an x squared term here already, so we need the x squared term in the expansion of this. Try cryptic crossword. Oh, sir, I am already... Actually, do you know what? This is so worth it, I'm going to stop the clock. I'm going to try cryptic crosswords. Yes. Sorry, I should have been checking the chat. No. This is more important than the paper. Right. So I'm obsessed with cryptic crosswords. Like one of my teachers in school taught me how to do it when I was like sixth form, sort of similar to where you guys are at. And I'm not that great at cryptic crosswords. I'm into like the Evening Standard Monday to Thursday. Evening Standard Friday, a little bit too hard. If you're into crosswords, though, I could tempt you with the New York Times cryptic. No, actually, New York Times doesn't have a cryptic. New York Times is just a standard one. But on the Sunday, they go bananas. They introduce really wild, like rule sets and like puzzles to it. The Sunday New York Times is great. A good accessible cryptic is Monday to Thursday Evening Standard. Or I think the Metro has a good entrance level cryptic crossword. Yeah. Oh, I had that phase. Don't worry. Cryptic crossword phase, Sudoku phase, New York Times crossword phase. Now I'm like all over the New York Times Games app. Like I'm that guy. I really like a good brain scratcher. So yeah, apologies. Okay. Now I promise I will actually start the paper. Alrighty then. You can have those 15 seconds. I won't put those back. Right. Now, this question. So x squared. So we know we need to have the x squared term in this expansion. So what's that going to be? That's going to be when I have 2x to the 4 and 1 over x squared, which requires a 6c2 in front of it. Which means it's going to be 6 choose 2, which is 1. I know 1, 5, 10, 10, 5, 1. So the next one is 6, 15. So it'll be 15 times, and 2 to the 4 is 16 times x squared multiplied by this x squared gives me my x to the 4. So 15 times 16 is 240, which is E. And that was question 1. Okay. So here, just knocking out the quick, easy questions. Hold on, let me just. Whoop. Super good at tech, I am. Right, question 2. Those are both factors. Well, that means that a root is x is minus a half, and another root is x equals 2, which means if I plug those both in, which is minus 2 over 8 plus p over 4 plus q, I will get 0. If I plug in 2, I will also get 0, which is 16. Obviously, I'll knock that down to a quarter. So that's 16 plus 4p plus q will equal 0. And what's my target? I'm targeting 2p plus q. So I'll keep my sights on that. Let me multiply this whole thing by 4. So that's going to be minus 1 plus p plus 4q equals 0. I'll multiply it by 4 again. 16q equals 0. So bottom minus top, that minus that is minus 3. That minus that is plus 3p. Sorry, not that. What am I talking about? Apologies for that. We're going to do this minus that. So no, we'll do top minus bottom. Okay, so that minus that is 20. Let's scroll down just so that you can see. That minus that is 20. That minus that is 0. That minus that is minus 15q. So 20 is 15q. So q is 4/3. And then can I plug that in easily? Q is 4/3, which means that 4p is minus 16 minus. There's 100% an easier way that I'm missing here. So I apologize for that. But I'd rather, you don't need to find the optimal path. You just need to find a path. Minus 52 over 3, and then divide that by 4 is minus 13 over 3, which means that 2p plus q is minus 26 over 3 plus 4 over 3 is minus 22 over 3, which is C. It's not related to TMUA, but how badly would one bad Oxbridge interview affect your chances of an offer? Depends. Honestly, depends on the balance and how they sort of communicate amongst themselves. Like, we'll see. We'll see. Yeah, just anxiously wait. It's a tough time. Tough time to be waiting on the offers to come through. Honestly, at this point, the best you can do is put it behind you. Just put it behind you, pretend it never happened, and just sort of wait and accept it come what may. Because realistically, if you don't get in, then that's them saying that the way they teach is probably not best for your learning style. And it's then important to go to your plan B, which is like find a good uni where you could be like towards the top third. That'll be really good for your confidence. Because a lot of people can go to Cambridge. If you end up towards the bottom, you feel like you're terrible, even if you're amazing. So that's the way to go. There's not really a bad outcome here. You either get in or you know you did your absolute best and you're going to the best university you could actually get into, and you can work really hard to be at the top of that, have a good work-life balance, and have a great mental health. Like there's no bad outcomes here. That's my advice. Now, question 3. If AB equals AC, which of the following must be true? Well, let's move this to one side and then factorize. So it is true that A into B minus C is 0. So A does not have to be 0. It can be. It's not that it must be true. That doesn't have to be true either. None of them have to be true. None of them have to be true. B could be equal to C, or A could be equal to 0. And if that was true, then it doesn't even, yeah, no. Okay, so 4. Let me zoom out a little bit. Nope, that was good. Consider the following conjecture. If n is a positive integer that consists of the digit 1 followed by an odd number of zeros. So 1 followed by 1, 2, 3, 4, 5, for instance, and then a final digit 1. Then n is a prime number. Interesting. So let's think about 1. 1 is not a counterexample because it does work. 2 is not a counterexample because the claim is not made about 2. The claim is because the claim is made about 1 followed by an odd number of zeros, then a final 1. So it is not making no claim about this with an even number of zeros. It is making a claim about this third one, which is not prime. So 3 is a counterexample. So it is 3 only, which is D. So question 4, by which I mean 5. I can count. I'm going to do real good in this math paper. Consider the following statement about the positive integers a, b, and n. So if a, b is divisible by n, then the condition either a or b. Okay, so let's think about this necessary and sufficient logic. So we have a condition which is true or false. So for true, it's either a or b is divisible by n. Blah, 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 blah. And then we have the results or the statement. So what are the conditions required for this statement to be true? So if the statement is true, what does that mean? It means that AB is divisible by n. So n divides AB. I think that's how you write that. And then the false is obviously it doesn't. So let's think about what this mapping actually is. If A or B is divisible by n, it is certainly true that AB is divisible by n because they're positive integers. And there's no way to have that not be true. That pathing exists, but I think this pathing also exists. You can also have n divide AB and n not go into either A or B. So an example of that would be 8 going into let's think about 10 going into 20. So 10 goes into 20. So 10 would be n and 20 would be AB, but 10 does not go into either 4 or 5. So that is possible, that pathing. So what this means is that this condition is sufficient but not necessary, which is B, because that is the sufficient mapping. Okay, moving on. Question 6. A student attempts to solve this equation in the range 0 to 2 pi. The student's attempt is as follows, which describes this attempt. Well, we can test this very easily by just trying it for x equals 0. Then that would be 1 plus 0 equals 0 minus 1, so it is not correct. So A is not true. So where was the mistake? As we look at this, let me zoom in so we can see it a bit better. As I look at it, I see that they've subtracted 2 sine x they've subtracted to the other side, and then they've grouped it accordingly. They've taken sine x out of this, sine x minus cos x. Huh? What is that? Okay, so sine tan, yes. Minus cos tan is minus sine, plus cos minus sine. I can see how that works. So this equals minus 1 or this equals minus 1 does not work. So I think 3 is the problem. Because what you really need is not just that this first one is minus 1, but that this second one is also 1 at the same time. And we need this to be equal to minus 1 while this is equal to 1 at the same time, and I don't think it considers that. So I think 3 is suspect. Let's carry on. So, but if that were true, I don't know, squaring can introduce new values, though. So if that one is true, then that is true, but squaring, that's also possibly suspect. Do they say anything about... Is that extra solutions were introduced on line 4? I still think the problem is 3, though. Well, it says first error. So if that were true, then 2 sine x cos x equals 0. I think, well, even if we take the second case, though, where tan x equals 0, that happens when x equals 0, which we showed didn't work. So it doesn't even matter that this has been squared. Even if that didn't happen, just considering the right-hand side, the or tan x equals 0, even without the squaring, the tan x equals 0 still introduces a solution that doesn't work. So I don't think the problem is the squaring has introduced extra solutions, so I'm going to go with D. I just don't like that logic there at all. For which of the following statements can this fact be used as a counterexample? Okay, first the claim has to be made about the statement, and then the statement has to be disproved. Sorry, the claim has to be disproved by the statement. If it's claiming... You'll get it. If a, b, and c are positive integers which satisfy this equation, which they do, and the 3 numbers have no common divisor. Well, the 3 numbers do have a common divisor of 4, so this statement is not being made, this claim is not being made about this equation. This could be written in the form if we consider the 16 to instead be 4 to the 4 plus 12 squared equals 20 squared. Then it is in this form. Has no solutions for which these are positive integers. I think B looks pretty good for that. I can't write 12 squared as anything to the 4, so the claim is not made about C. It doesn't fit. And if these satisfy this equation, then 1 is the arithmetic mean of the other 2. Well, the 16 is the arithmetic mean of the 12 and the 20, but that confirms it. That doesn't counterexample it, so the answer is B. Question 8. A, B, and C are real numbers in that order. Which of the following statements must be true? They're real numbers and they're all negative. Got to bear that in mind. So this is, AC is 2 negative numbers. So negative times negative is positive. So these 3 are all positive. So the signs get canceled. And in terms of the magnitude, why don't I write this? So 0 is less than the magnitude of C, is less than the magnitude of B, is less than the magnitude of A. So A was the most negative, so it has the biggest magnitude. So when I multiply AC, and then the signs cancel, then AC is positive, and that will be I think one does work. I think AC will be less than AB will be less than A squared on that basis, so I think one is good. In the second case, C plus A will be negative multiplied by the negative number of B. Yes, that will be greater than 0, so I think 2 is also good. Am I missing anything? Nope. Negative plus negative is negative times negative is positive. That just works. And in this case, so C over B, the signs will cancel, we'll make that positive. This will also be positive. They're both divided by B, but this is not true because the magnitude of C is less than the magnitude of A. So C over B will just be equal to the magnitude of C over the magnitude of B because the signs cancel, and that actually is less than the magnitude of A over the magnitude of B because magnitude of C is less than magnitude of A. So 3 is not correct, so 1 and 2 are correct, so that is E. Okay. So far, so good. Waiting for it to get tricky. Hope I didn't just jinx it. So a large circular table has 40 chairs around it. What is the smallest number of people who can be sitting at the table already, such that the next person to sit down must sit next to someone? Okay, so the way I'm going to do that, so we have to place them clearly every third seat. So it'll be 1, 4, 7, 10, 13, 16, 19, 22, 25, 28, 31, 34, 37, and then 40 is already next to the 1 because it loops round. But then someone can be sitting in, no one can be sitting in 38, but the next person could sit in 39 and not be next to anyone, but then the next person has to sit next to someone. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is D. And I like that. Skip, skip. Yeah, every third up to 37. 40 is, I can't put 40. 40 is already taken. 39 though would, yeah, I think that's good. Always worth double checking the logic ones just to make sure your process is okay. Okay, so we've got a quadrilateral labeled anti-clockwise. Okay, parallelogram. I'll just draw a few variants. So PQRS labeled anti-clockwise. That's clockwise. Oh man. Luckily, those basic skills are not the ones that get tested. All right, so RS. Now, which of these are necessary but not sufficient to be a parallelogram? If PQ is equal to SR, yes, that is, and PS is parallel to QR, yes, that is necessary. Is it sufficient? If these are the same, if these are parallel, and these are the same length, yes, that is sufficient. So it's not A because that is necessary and sufficient. Let's try the next one. So PQ equals SR, and PQ is parallel to SR. That is certainly necessary. Is it sufficient? Can I come up with something where that is true and it is not a parallelogram? If they're parallel and equal length, I think that might be sufficient. PR equals QS. Well, that's actually not necessary. So this is a parallelogram, and that's not true. The sides don't all have to be the same. That is certainly not necessary. So it actually is one of these previous ones. So what am I missing here? If PQ equals SR and PS is parallel to QR. And PQ, okay, so if they're equal and parallel, well, I'm thinking for B, if they're equal, and why am I messing up on this? Okay, let me just draw some of the other things it could be. The problem is that square, rectangle, rhombus, and parallelogram are all subset of parallelogram. So the only other thing that it could be is trapezium, where they are parallel, but these other two are not. But they can't be the same length, because if they were the same length, then these other two would have to be the same length as well. Or it could be a kite. But again, nothing's parallel in a kite. Oh, hold on a minute. PQ equals SR. Huh. I can't believe this is the one. I can't believe this is the one I'm not. I'll come back to it. I'll come back to it. I'll make a note to come back to it. I'll take this with fresh eyes. It's not worth burning time over. 20 minutes in, not doing too badly. I'll have time to come back and have another bite of that apple. So here, God, let me give myself a bit more room. In fact, hold on. Just going to quickly shut down the textbook I have behind that in case of any copyright issues. Okay, so what am I looking at now? Yeah, good generic background. Right, so arithmetic series has n terms, all of which are integers, the sum of which is 20. Which of the following statements must be true? Well, that means that 20 equals n over 2 into 2a plus n minus 1d. We know this. Doesn't that have to be true? The first term of the series is even. I don't see why that has to be true. Well, I can tell you for a fact that's not true. Because if I had an arithmetic series of 119, full stop, the end, a equals 1, d equals 10, 20, a equals 1, d equals 19, n equals 2, bam, those sum to 20. Okay, n is even. Can I come up with an arithmetic series? Well, I think the reason why they're saying that is because of this fraction. But I think if d was even, then n doesn't have to be even. So let's say d was 2. Could I have an odd number? Yes. 5, 3, 7, 1, 9. That's a equals 1, d equals 2. Those sum to 25. Oops. Which case I should have done the opposite. I should have done 4, 2, 6. No, what did I mean? So let's say there were 5. The average of them would be 4. So it could be 4. Two, 6, 0, 8. Yeah, that sums to 20. So the a equals 0, d equals 2, n equals 5. That works. So 2 does not have to be true. And this is a very common case in the TMUA of finding counterexamples to make your point. The common difference is even. It is in both these cases. Can I find one where the common difference is odd? Well, if that's odd, and n was also odd, then it could work, because then the 2 would cancel out that way and I could get an integer. So if d was odd, so the common difference is even, so the common difference is odd. Well, let's just, if n was odd, right, so I could also, so let's say I had, if n was odd, so again, 5 numbers, instead of that, I could have said, 2, 3, 4, 5, 6. Because 8 plus 4 is 12 and 8 is 20. So that with a equals 2, n equals 5, d equals 1. That also disproves 2, but that also disproves 3. And that works. And here I could get one with it. So none of them have to be true, and the answer is A. Okay. That was a lift. Whoop. Okay. So 12. Checking time. So, okay. Most students in a large college study math. Teacher chooses 3 different students at random, one after the other. Okay, so 3 different students. Large college. So I'm guessing that means the denominator is roughly constant. So let's assume a constant probability of a person doing math. So let's say P equals probability of just someone doing math. Okay, so the first one is the probability that at least one of the students studies math. So at least one would be, so R equals 1 minus the probability that no one studies math, which is that person not studying math cubed. Which I could simplify. Do I feel like it? Go on, why not? So 1 minus 3p plus 3p squared minus p cubed. Subtract that off without making a mistake. Then it becomes 3p minus 3p squared plus p cubed. Okay, cool, that's R. S. S is the probability that the second student studies mathematics, which is just P. And bear in mind, P is between 0 and 1. And then for T, all 3 students study mathematics. That's just P cubed. Okay, well, so that is equal to P times P squared. And that is equal to P times P squared minus 3P plus 3. And the reason why I say that is that might help us compare RS and T. So T, you're multiplying by P squared, and P squared is certainly less than 1. So T is certainly less than S. I can give you that for free. Now, where does R fit into the mix? Well, this thing, let's compare R and T. That'll be easy because they're both P times P squared, and this one's got some stuff. So if I add 3 to that, that's a fraction. So that doesn't subtract us all the way back. So that is certainly bigger than P squared. So I think R is bigger than T. But does it slot in between? How do I compare? Is this thing, let me consider this quadratic for a second and just consider whether this thing is bigger than 1. So in this interval, or rather, so I know it's going to be T is on the bottom. Yeah, I just need to consider that order. So let's consider, so this would be p minus 3 over 2 squared minus 9 over 4 plus 3, which is p minus 3 over 2 squared plus 3/4. And if I sketch that real quick, this turning point is at 3 over 2, so it does something like that. So that is 3 over 2 and 3/4. When p equals 0, that bit equals 3. When p equals 1, this equals 1. So this term is actually always in this interval between 1 and 3. So it is bigger than p. So r is bigger than s. And I think the answer is F. Sweet. Man, you really got to walk a tight line with this paper, don't you? Okay, so 13. So we're integrating sine squared of x between a and b using the trapezium rule with 4 strips. The resulting approximation is an overestimate. Okay, well, I've seen this before. Let's think about the ways that something can change on an interval. So these are the 4 possibilities. If I draw the straight lines in between, we can see that this would give an underestimate for the trapezium rule. This would also be an underestimate. This would be an overestimate. And this would be an overestimate. So for it to be an overestimate, the graph has to be looking like this or this. And if I know the shape of the sine squared graph, which I do, I know it's going to go like this. So we need bits where it is sort of concave. So we're talking about like sort of on this interval, for instance. So what is necessarily true? If the student approximates, well, this is now going to turn into maybe evenness and oddness. So the sine squared I know is an even function. It is symmetrical about the y-axis. So I know that f of minus x equals f of x. So I know that integrating on that interval, the result should be an overestimate similarly, because it should look exactly the same. Or rather, let me give a representative. So I'm sure that's to do with it, because every point on that integral interval will map perfectly onto a point here between a and b. So the integral of y dx should be exactly the same. Maybe I can consider, so this, for instance, like on this integral, it will work. That will definitely be an overestimate. That mirrors onto this bit here, which, yes, it would also be an overestimate. I think 1 is necessarily true. I won't do that because that'll look like an answer. So 1 is definitely true, I think. If the student approximates cos squared in the same way, the result would be an underestimate. Well, that actually gets more interesting, because that is the integral on the same interval of 1 minus sine squared x, which I can write as the integral from a to b of just 1 dx minus the integral from a to b of sine squared x dx. Now, if this thing was an overestimate on that interval, then when I subtract too much, I end up with too little. So this should be an underestimate. And I think that is also necessarily true. So I think the answer is D, both of them. Okay. Keep on getting the formatting just off, but whatever. Hopefully the viewing experience is not too bad. 14. Consider the following statements about the polynomial. I've been burned by that before. That is a polynomial, not a general function, where a is less than b. Which of these statements is a necessary condition So to be necessary, again, condition, results. Necessary means I can only arrive at that thing being true if that thing is true. So condition, and then the result is P of X increasing. I'm looking for something that has this sort of mapping, where if the condition is true, it means that P of X is increasing. And if the condition is false, it cannot be increasing. The only way to arrive at P being increasing is to start with the condition being true. That's what I'm looking for. In order to test that, I'm going to see if the condition can be false and P can still be increasing. So, for 1, can A be less than B? Sorry, can the condition be false and it still be increasing? For the entire thing, I think, again, let me get into the fine points of it. Let me check my timing. 40 minutes left. So I think here, to be increasing for that, I think it means increasing for all of that, which means it should be getting bigger, because I think what that means is that, let me sketch something representative, right? So it means it's doing something like that. To be increasing between A and B, I think 1 is necessary. I do not think that at A you could be bigger than here and have it be increasing for that interval, because it ends up smaller, so it has to have decreased at some point. So 1 is necessary. Is it necessary that the gradient? No. It is. 2 is not necessary, because let's come up with, so if I did something like this, for instance, then the gradient here would be bigger than the gradient here, and yet it is increasing. So 2 does not have to be true. 1 is in, 2 is out. Does the second derivative have to be less? Well, let's consider a case then where the second derivative is bigger, which means the gradient is increasing faster at A than at B. So that might look something like, or not even increasing faster, but like, the gradient could be increased. So no, this doesn't have to be true. Or rather, I can show you even better. Well, let's take even this example. So here the gradient is changing more quickly than it is here, or especially here, the gradient is pretty much flat. So here, this would be pretty much 0, but this would be, oh, I suppose it would be decreasing, so that would be smaller, so that would be true. Let's consider, well, let's say here it is getting, the gradient is increasing a lot. And actually here the gradient can be decreasing. So if it does something like this, like a sort of sinusoidal thing, for instance, then here the gradient is increasing, here the gradient is decreasing. But it is still increasing on this interval. So second derivative at A would be bigger than the second derivative at B, and yet it is still increasing. So 3 is not necessary. So 3 is out. So it's 1 only, which is B. Okay. Cool. This looks fun. I quite like log laws. 15. Numbers A, B, and C are each greater than 1, which is important because log of 1 is 0, which means the logs of all of these are bigger than 0. So the logs are positive. Got it. Or all to the same base. So I almost just don't want to have to write all this out, but whatever. So this thing equals 7. This thing equals 11. And 2 log A, 2 log B, 3 log C is 15. 3 unknowns, 3 equations. Ooh, what is the base? Maybe that was the wrong approach then. Hold on a minute. So what that would mean is that AB squared C is equal to the base of D to the 7. A squared BC squared is the base to the 11. If I divide those... No, let's... No, we can get there from the logs. Let's get there from the logs. I think it'll work out the same. So from these two, if I do the bottom, the third minus second, I will get this minus this is 0. This minus this is log B. This minus this is log C. This minus this is 4. Great. So that's by eliminating log A. So let's say then that log B is 4 minus log C. I can shove that into the top equation and get that log A plus 8 minus 2 log C plus log C is 7, which means that log A minus log C equals minus 1. I can also shove it into the second equation and get 2 log A plus log B substituted in plus 2 log C is 11, which means that 2 log A plus log C equals 7. I then have these two to solve simultaneously. If I add them together, I get that 3 log A equals 0. The plot thickens, which can only happen, I think, if A equals 1. No, but it's... No! Did I do something wrong? Okay. Did I get that? I'm going to come back to this with fresh eyes and maybe try a different attempt, different method. Okay, so good exam technique. Because I want to make sure I've got half an hour left. I want to make sure I have a good attempt at all the questions. So this thing intersects the x-axis at 2 distinct points. In which one of the following graphs does the shaded region show the complete set of possible values that P and Q can take? So if it intersects the x-axis at 2 distinct points, that means the discriminant is bigger than 0. So Q squared minus 4P squared, that is bigger than 0. That is difference of 2 squares, Q plus 2P, Q minus 2P. It's bigger than 0. Okay, so the limiting cases here are when Q equals 2P and Q equals minus 2P. So I'd expect those to be my lines. So F is a candidate, E is a candidate. There's literally, oh, it's just a matter of which side. So I think it's between F and E then. And then in the case that Q is bigger than 2P, what will happen, that's meant to be 2P, is that this thing will be positive. Well, in fact, what I can do is I can get a range of P's. So when P is... So between minus 2P and then from 2P, if I consider separately what these things would be, so Q plus 2P and Q minus 2P, up to 2P, So this would be more negative than that is positive. So that would be negative, and this would be negative. Then in between, so here, this would be less negative. Or even so this would be positive, and this would be negative. Then here, this would be positive, and this would be positive. So when I multiply them together in these regions, when Q is less than minus 2p, and when Q is bigger than 2p, then I will get what I want, and that happens in F when Q's are above the 2p line. Okay, so that's F. Okay, let's lock in a few more of these because I've got some to come back to. Exactly, one of these is correct. I've seen this before, or at least questions like this. 17. Right, if A is true, then B is also true, so it's not A. If C is true, then it is true if X is bigger than true, so it is also, then D would also be true, so it can't be C. If D was true, that's interesting. So let me show you what would happen here. So X is bigger than 2. X is less than or equal to 2. But that's if. So if that, then that, and not false. But that could also exist. And included in that could be something between 1 and 2. By which I mean... No, what do I mean? What I mean is, let's say... it's if, but not only if X is bigger than 2. And same thing here. It is true if X is bigger than 1, but not only if X is bigger than 1. So in other words, if I had a number line, it could be true for 3 and above. If it was true for 3 and above, then both statements B and D would be correct. No. No, it wouldn't be. If X is bigger than... Okay, let me write a number line. So X is 1, X is 2. So if it's the first one, if X bigger than 1, then true, would also include statement D. Because although X is bigger than 2, it would be true for, so D would also be true, so it can't be B, so it has to be D, is what I think. So it is true for X is bigger than 2. Which does not necessarily include... see... No, I think I've got this wrong, because it's not only if. I think I was right the first time. So X bigger than 1, X less than or equal to 1. No, was I right the second time? All right, okay, I had some logic. I'm gonna stick with D and maybe come back to it if I have time. Let's make a note of that. I'm feeling kind of defeated conceptually today, but I don't feel too bad about that. So this is just sort of not nice. Okay, so how long have I got? 25 minutes. Yeah, that's decent time. Consider the following inequality. So A, mod x plus 1 is less than or equal to x minus 2, the modulus of that, where a is a real constant. Which one of the following describes the complete set of values of a such that that statement is true for all real x? So what I'm going to first consider is the graph of mod of x minus 2, which obviously is a v kind of cutting through here, where that's 2 and that's 2. Let's label y and x. Now, the mod of thingy plus 1 is going to do that. It's going to cross at 1 when x equals 0. And it's going to have a gradient of a, both sides. Which of the following describes the complete set of values of a such that this is true for all real x? In other words, such that this guy is always less than this guy. Well, okay. So, in other words, well, that's interesting, because clearly here that's not true. Clearly there are places where there can't be such a value of a. Let's just choose the point x equals 2 for all real x. Well, 2 is a real x. Let's consider x equals 2. When x equals 2, you would have 2a plus 1 needing to be less than, oh, it could be negative. Could be negative. Would need to be less than 0. So a would need to be less than minus a half, certainly. Well, I suppose it could be equal to. Okay, so in which case, let me consider this differently. So I've got that there. Let me redraw my condition on modulus of x minus 2. Then this needs to be 1, and it needs to, certainly a has to be negative. So it has to be 1 minus this. It has to do something like this. And it can just never touch there. So a can be negative. A can be very, very negative. So it can go from minus infinity to a up to a certain value. And that would be this point where the gradient between these two things, which is minus a half, going across 2, going down 1. So a is less than or equal to minus a half, works. And then this would be less for all of that, for all x, certainly. And I think the answer, therefore, is E. Cool. 19. This looks like fun. I like the look of this. I'm going to enjoy myself. So the reason why I think this is fun. So let's say, I wonder if that's written like that for a very particular reason. Because it almost looks like you can factorize that. Huh. Square the first, square the last, and twice the middle too. Well, if that was a squared, it would have to be 2 root 2. So let's consider 9 minus 12 root 2 plus 8 first. So it would have to be 3 minus 2 root 2 squared. And it is! Square the first, square the last, and twice the middle too. We're on to something, because then you square root that. But I wonder if this is to do with the fact that when you square it, you have to get the positive square root. And you need to consider which of these is bigger. That's good. Oh, this is going to be fun, guys. Oh, I'm going to have fun here. This is going to be great. And then 8 minus 4 root 2 plus 1. I think that has to be, because if that is square the first, that comes from 2 root 2. And if that's square the last, it's that squared. Because then it would be square the first square less than twice the middle 2. Great. So now we have the root of 2 root 2 minus 1 squared, where you have to know that square rooting in this format means taking the positive root. And same thing here, 3 minus 2 root 2 squared, taking the positive root. Now we need to consider which is bigger. So clearly here, so in other words, if we square rooted that, it would either be 2 root 2 minus 1 or 1 minus 2 root 2. Root 2 is bigger than 1, so this 2 root 2 is certainly bigger than 1, so this would be negative. So we want this one for that part. Now, how do I compare 3 with 2 root 2 so I know which one is bigger? Well, let's compare it. So 3 is going to be either bigger than or it's good, some level of comparison with 2 root 2. If I square both sides, 9 and 8. 9 is bigger than 8, so 3 is bigger than 2 root 2. I think I'm happy with that. I think root 2 is around 1.4 something, which is less than 1.5. So which means we also want to take that as positive. So it becomes 2 root 2 minus 1 plus 3 minus 2 root 2, which is 2, which is E. That's bananas. Oh, that was fun. Okay. So 20. How am I doing on time? Because I'll have time to go. Yep, doing good. Doing good. I'll have time to go back. So in the graph of that function defined on real numbers is reflected in the y-axis and then translated, well, let's do that in order. So then it would become y. So reflected in the y-axis means f of minus x. And then it goes to, then that thing is translated by 2 units in the negative x direction. Oh, no. Okay. I know how to do this, because if I have so we're going to so we take, I'll call that x bar. We are first going to negative it, and then we are translating by 2 units in the negative x direction. And I'm going to call that x, and then I'm going to rearrange it and make x bar the subject of the formula. So minus x bar equals x plus 2, x bar equals minus x minus 2. So g of x is equal to f of minus x minus 2. Oh, come off it. Okay. Then, oh, sorry, when the same y of f of x. Okay, so then minus is translated by, so we're going to change the order. So this time we're going to take x dash, we're going to translate it by 2 units in the negative x direction, and then negative it. And we're going to call that x, and we're going to make x dash the subject. So when I do that, then x dash minus 2 equals minus x, x dash equals 2 minus x, which means that h of x is equal to f of 2 minus x. So for these to be identical, then that would have to require that f of minus x minus 2 would equal to f of 2 minus x. Now, I can substitute in. So let me plug in a minus x into that. That would give me f of x minus 2 equals f of x plus 2. And then if I substituted that with x plus 2, I would get f of x equals f of x plus 4. So I think the answer is B. Woo! I'll explain that one if I'm right. All right, so I've got time. So 10 and 15 I had to go over. I didn't like 10. I did like 15. I want to have another go at 15. Are each greater than 1. So let me try the thingy. So let's say that ab squared c is equal to d to the 7. And a squared bc squared equals d to the 11. If I square that up, I get a squared b4c squared equals d to the 14, which would mean that, that divided by that means b cubed, that divided by that equals d cubed. And the only way that's possible is if b equals d, which is b. Can't be that simple, can it? Let me just check that. Let's take log to base. Well, okay, let's say a base could be determined, then it's not e. Then the base exists and it's either a, b, c, or something else. So testing for b would be fine. So let's take log to base b. So that would be log b of a plus 2 plus log b of c equals 7, which means that log a plus log b equals 5. On this one, 2 log b of a plus 1 plus 2 log b of c equals 11. Knock that across makes that 10. That's consistent. Does that work on the third one? 2 log b of a plus 2 plus 3 log b of c is 15. Knock that across makes that 13. I think it works because then log b of c would be equal to 3. And so c is equal to b cubed. And then from up here, it means that log b of a is equal to 2, which means that a is equal to b squared. So in other words, log to base b, so it's b squared, b cubed is b to the 7, which would be 7. This would be 4 and 1 and 6, which is 11. And this would be 4 and 2 is 6 and 9 is 15. It works. It's base b. I cannot. Okay, so much easier the second time. I even checked that because I didn't trust myself. I've got 13 minutes left to finish 10 and check 17. And then check I haven't done anything silly. Because typically all my mistakes have been on the ones I didn't think I was getting wrong. So let's try 10 again. Okay, necessary but not sufficient. So I do need it, but I also need something else. As in, this by itself is not enough. So PQRS. I think opposite sides are equal, opposite sides are parallel. It is not necessary that all 4 be the same length. It is not necessary. Oh. Oh, maybe it's just me being silly. Maybe these first two were both necessary and sufficient. Maybe it was D. Because my two examples, PQRS, Oh, no, PQ equals QS. No, the diagonals don't have to be equal. That is not necessary. So not necessary, not so it is either A or B. God damn it. Okay. So, what do I know about parallelograms? I know that in order for these to be parallelogram, opposite sides are the same length, not necessarily the same as each other, like on that one, and that they are parallel. The angles do not all have to be the same. It could be a rectangle or a parallelogram, and these could be different lengths to each other or the same. So PQ equals SR, and PS is parallel to QR is certainly necessary. PQ equals SR, PS is parallel to QR. I'm going to really, really kick myself over this one. PQ equals SR and PQ is parallel to SR is certainly true. So given that it is one of these two, because that's not necessary. It is not necessary that all the lengths be the same. It is not necessary that the diagonals be equal length. So one of these is necessary. So one of these things must be true, but it is not sufficient because I need something else to be true as well. Or those things could be true and lead to something that's not a parallelogram. One of these things being true could lead to something other than a parallelogram. Is it being really annoying in defining parallelogram narrowly? And PQ is parallel to SR. I'm just going to play the exam technique here and say it's B because it also requires something of these guys. Because if these are equal length and PS is parallel to QR, I think it's forced. So I'm gonna just tactically guess B to give me enough time to check 17 and then anything else I need to check. I don't like that though. Like, yeah, I didn't like this either. Okay. So I knew it was between, okay, I like how I got rid of the if and only if, I think. Oh, maybe not. I'm just gonna have to write out all four mappings. X bigger than 1, X not bigger than 1. True, false. Second one is the same. I'm going to consider, and then the same for 2. I'm going to cut this down the middle. True, false. X is, because I've never really been that great at these. Your advice for engineering interviews was so good. Glad I could help. I'm glad you found it helpful. If you could give me some advice back about this question, that would be great. I'm just kidding. No backseat driving. I've only got 6 minutes before the time's up anyway, and I checked the answer. Here. So true if and only if would be this mapping. If this, then true and not false. This mapping is what that means. So that is the A mapping. That is the B mapping. The C mapping is if and only if, which goes like this. And if goes like this for D. So only one of these is true. Exactly one of these options is correct. Oh, maybe it's C because it's the most restrictive. Okay. Hear me out. If and only if x is bigger than 2. So let's consider a timeline or number line with x is bigger than 2. And let's say that had to be true. What is this region of truth contained in? This would be contained in A. Because it would still be true that x is bigger than 1 in the truth zone. Wait, no, but and only if x is bigger than 1. Yeah, yeah. Because if x is bigger than 1, which it is here, then it would be true, and it is not true anywhere else, so it would still be included in A. If this was the area of truth, this would be triggered. No. No, maybe this is the way to think about it. So if and only if. So this is what. So C includes that and only that. A includes that and only that. ESAT live streams before January 6th. Yes, I'm definitely going to do that. I've been prioritizing this because this is where most of my student base is at the moment. But yes, I'm going to do ESAT. Plus, I think I've got a decent string of the solves out there, so I'm not sure it would be that additive at this point. How well do you think the TMUA does its job? Really, I don't know that it does a great job for people going for like econ. But hey, like you can see, I'm just like struggling here. If B equals 1, but not, it could be other things. But not only if B equals 1. Other things can also get you to truth. My head hates this stuff. I find it so tricky. I'm just gonna, Okay, B is the least restrictive, C is the most restrictive. So I feel like it's either going to be B or C. Oh, okay, so I got 2 minutes. There is a truth, and the truth is only completely contained in 1. So if this was the truth, if there was a truth found, and let's say it was actually, the truth was here, then it would be captured by all of them. And so I think I want. Did I say B first time? Okay, so it has to be in such a way that the other things are wrong. So let's say the truth was so like that was the truth. I think it's A. I'm going to swap my answer to A. Man, I hate this question style. I'm going to swap my answer to A. Because it restricts it to the bit that this would yeet C and D, and B is a bit loose. So it's without the only if, and I've only got a minute on the clock. I'm going to swap it to A, 17. And because I only have a minute, I don't really have the time. I'm going to swap to the other end of the, yeah. I don't have time to check anything else. So yeah, we'll call it there. Right. I think it would be great if you could throw in some ENGA Section 2. Problem with ENGA Section 2 is that's not part of ESAT. ESAT is very much just the amalgamation of Section 1s. Section 2 is good for like interview prep. Hold on, let me. So, but the thing is though, from the ESAT, from the version that was available online, it really is just the Section 1 that they compiled with the NSAA and the ENGA. So I'm not sure that Section 2 would be much good, like use to you. But you're right. I'll stick in another. I'll stick in another Section 1 run certainly, because I think I only got down to 2018, so I might do a 2017 run just to put that through. Making sure, in fact, I should still be taking the Math 1 from ENGA Section 1 and the Math 1 and Physics from NSAA. ENGA Section 1 is too easy. Yeah, but like that's, if you look at it, that's what it is. If you so the online UAT version that's available, it just steals questions from there. We'll check Practically Anonymous. I'm not confident on my answer at all on that, but like, we'll see. I'm gonna mark it up now. I hate that stuff. Because I've now gone through all the options. Right, no, okay, it's time to start marking up and going through the explanations. Making sure I've got a hard stop at 6:30, so making sure I get it done before then. Right, question 1. Let me start sharing screen again. 1 is E. Also, I wanted to ask how you can tell if you have a good engineering interview. You can never tell if you've had a good interview. You just can't tell. Like a lot of people think it went bad when it went good. A lot of people think it went well when it didn't go so well. Like I would just say, but also it's not actionable information for you anymore. Like if you knew you did badly, what would you do about it? If you knew it went well, what would you do about it? At this point, the flowchart looks the same. It's just sort of carry on and wait for an offer either way. So I would just sort of say, yeah, it went. Don't think about whether it went well in the absolute, because that I think is sort of like, I want to know. I want to sort of brace myself for either a yes or a no. Sit in the uncertainty for a bit, because it will get resolved with certainty in like a month's time. So you don't know, but I don't think you need to know. And I think that's okay. So going back to here. So zooming in on this. So the answer is E. Good. Here the answer is C. Good. A. Good. D. Good. B. Yep. D. Yes. Whoop. Then, sorry, that was question 6 is D, 7 is B, 8 is E, 9 is D. Good. 10 I didn't like. I'll come back to that. 11 is A. 12 is F. 13 is D. 14 is B. 15 I came back to. 16 is F. 17, moment of truth. Oh, the answer was D. No, I had it right. I talked myself out of a correct answer. No. Everything's fine. Just a test. It's fine. Everything's fine. God, I hate when I do that. All right. No. Okay. Fine. I'll grumble. Come back to it. 18 is E. 19 is E, boom, smashed it. 20. Let's see if I got that right. Which is option? Smashed it. Boom. All right, I'll explain how I do multiple X transformations. Let's go back. 15 was B. 10 I just didn't like at all. Correct answer is A, not B. Right. Okay, so we'll go through 10. In fact, let's go through 10 now. So 10 was the one about the, which one makes a parallelogram? Oh, god damn it. Yes, of course, they can be equal in length. And these two are parallel, so that is, so A is the, yes. That is so frustrating. I didn't consider they could be equal in length acting in different directions. Yes. Of course, I didn't properly consider this. That's frustrating. So again, I seem to be stuck on a ceiling of 18. So PS is parallel to QR. So PQRS, these are parallel. And these two are the same length. That makes a trapezium. Should have got that. Okay, so that was A. And then 17, I just hated, and I had the right answer and talked myself out. 17, let me find it. Okay, how should this have been done? As exactly one is correct. Option A implies option B. No, I was right the first time for exactly the same logic. Hold on, let's see how I did it before. Oh, that's so annoying. I argued it couldn't be A because A includes B. It couldn't be C because C includes D. Now let's consider B and D. If B was correct, whenever X is positive, yes, the statement is true, which includes that. Oh man, I had it, guys, I had it. 19 was on the cards. Oh, why? Oh, man. Okay. That burns. Upset by that. Upset by that. Right. Okay, but man, at least I had, at least for your perspective, you have a good explanation. I think it's the first time I've talked myself out of a correct answer on stream, so that's fun. Love that for me. Today was going to be the day as well. I was so on it. I had the 19 in my hands. All right. So 1, I think, was self-explanatory. 2 was just simultaneous equations. Yeah. 3, as I said, doesn't all have to be true. So either, yeah, you could have alternatives. In fact, let me do it from the question so you can actually see what I'm talking about. So here, yeah, and then 4, as I said, the claim was not made about it. 1 is fine. The claim was not made about 2, so 3 was the only answer there. So yeah, the antecedent is false, as they say. I also wanted to, oh, hello. The form is not correct. The form is correct, and the consequent is false, so it is a counterexample. Great. 5. Yep, this was fine. Let me see how they argued this. With words. How did I argue it? That's important. What, can I even remember what I did? So if one of these two is divisible by n, then AB is certainly divisible by n. So it is necessary. Sorry, it is sufficient, but it is not necessary because there is another way of it arriving at AB being divisible by n, as I demonstrated with the case that n equals 10, A and B are 4 and 5. Because 10 does not go into either 4 or 5, but 10 does very much go into 20. So therefore, you can also have the condition not being true and have the statement being true, and this is sufficient but not necessary. Okay. D. I'd love to hear their reasoning because I'm sure I was correct about this. Yeah, the incorrect solution x equals 0 in line 3. So they tested, okay, so they tested x equals 0 here. And it worked. So the error has been introduced by this point, and it wasn't introduced at 1 or 2, so it had to be 3. Because this would be true if dealing with integers, but we are not, so it's an invalid implication. Oh, so they're really just saying for this to be possible, one of them has to be equal to -1, but that doesn't have to be true. Okay. 7, I really like the way I explained that. So I think there's nothing more to be said about that. 8, I like how I did this as well, considering the magnitudes and the signs separately. Okay. 9, I really like how I did that. Let's see if they had a better way. Nope, they did it exactly the same. The final person is sitting immediately next to the first person, but that does not matter. It does matter. So there are 14 seats, and the answer is D. I think mine's better than their way. Not to be petty about it. 10, I'm not even talking about. Go away. 11, I liked. This is very TMUA, coming up with counterexamples in each case. N equals 1, A equals 20. They came up with an even easier one. And 2, 3, 4, 5, 6 gets rid of 2 and 3, as I found. So if you can come up with counterexamples, that's the way to go in TMUA. Question 12. I really liked how I did that. Oh, they just did it a generic way. Mine felt more rigorous. I liked mine. Then certainly the second student studies it, and at least one of the other students. Oh, so if all 3 is the most restrictive. So they argue this more from a sort of high level perspective. If all 3 students, that contains the condition on S and R. Okay, so T is less than both. That makes sense. If the second student studies, oh, right, so that's even more restrictive. If S is true, then R is also true. So S is contained within R, so S has to be less than R. Clever! I liked my little rigorous way where I calculated it in terms of the general P. But yeah, I suppose from their perspective, that does work. They just considered subsets. So T is contained within S and R. So the probabilities of S and R in total have to be bigger than T. And similarly, S is contained within R. So the probability of R has to be bigger than the probability of S. And I could have saved some time on that, but I still got it right. I liked the argument on 13. I wonder if they did the same thing with even and odd. So yes, they also considered, okay, so they drew the graph, fine. They shouldn't have considered it over so many intervals, just saying. So right, because it's a reflection, it's just the same strips reflected, so still an overestimate, like I said, from this point down here. For 2, and yeah, it was just 1 minus the thing. So it's something minus a constant minus an overestimate, giving an underestimate, so that's why that worked. 14, yeah, just sort of giving examples, trying to knock them down in both cases. I like that I use my mappings here to give me something to test. So I want to test that the condition is false, and yet the function is still increasing on the interval. Let's see how they did that. Yeah, that is a necessary condition. And then they just did counterexamples in both cases. So constructing counterexamples is a very important skill in TMUA. So it's just like I did, they considered one where the gradient is more positive here and less positive here. So still increasing, even though the condition is not true. And here, if I have that kind of negative cubic shape, then here the second derivative is bigger, positive, that's negative. So here it's clearly bigger. So it's not necessary. 15. Did they do it the logs way? They did. I must have just made some arithmetic error. I don't know where, but that's fine. So I'm sure if I redid that, I would have been fine. But yeah, just the simultaneous equations get the job done. So the answer is B. I like that I didn't get bogged down. I just sort of moved on, came back to it with fresh eyes, and then it just fell apart in my hands. It was great. 16 I liked. So yes, exactly the same reasoning is what I made. So difference of two squares that. So either q is less than minus 2p or q is bigger than 2p. And then I like that I do this table as well. So considering different regions of q and what that means for the individual expressions that I multiply together. So here, when q is less than minus 2p, this thing is negative. This expression is negative. Well, both expressions are negative. So when I multiply them together, I do get a positive number. Here, in this middle interval, the plus term is positive, that term is negative, so it's overall negative. And then here, both terms are positive, so we get positive again. So we needed q is less than minus 2p, which was this shaded region here in F, and q is bigger than 2p, which is this shaded region here in F. So that was 17, I think. Nope, that was 16. 17, I can't talk about that anymore. That just hurts. 18 was right for exactly the reasons that we discussed. So if it was positive, it would never work. So it has to be negative. And then that's the limiting case, which is E. So yeah, I did it right using the right method. So here they spotted exactly that. They spotted the... And I like as well that I had to consider which one the positive square root would be. And then you add them together and it's E. I do not like the squaring it method. Yeah, we're left in an even worse situation than you started with. No, that's not it. They wrote it out that way very specifically. That felt intentional for me to see. And yeah, that looked like a square the first, square the last, twice the middle too. Which is how I was able to get that very easily. Now, let me talk about 20, because I'm so curious how they did it. To take a piece of paper and physically move it around. Okay, here's my method, right? I teach this method more the reverse direction, right? So this is the method I teach when you have like, so I've seen, so like, let's say I have sine, right? How would you describe? Oh no, I have seen it. I'm not sure if it was no, it was a TMUA. It was a TMUA. So let's say we had something like sine of 2x plus pi over 4 or plus pi over 2, and you had to describe what that does. Intuitively, you might want to say that first you shrink it by a scale stretch it by a scale factor of a half in the x direction, and then shift it by pi over 2 in the negative x direction. But that wouldn't be true. And if you want to know how to sort of undo, if you want to look at this function and know what that does, practically speaking, what I always advocate for is take that thing in the bracket and set it to an like something called x bar or x dash, and then make x the subject of the formula. So here 2x is equal to x dash minus pi over 2. Dividing by 2, we get x dash over 2 minus pi over 4, where x dash is the original. So actually, you take the original, you divide it by 2, but then you move it pi over 4 to the left, not pi over 2 to the left. And that always works. So this transformation is the stretch by a factor of a half and then a shift of pi over 4, not pi over 2. So I knew I had that in my back pocket. So when I was seeing this, I went, okay, let me try that in reverse. Where instead, like I knew, okay, take the original, do some things to it, and then that would give me x. But I knew if I could work backwards, so if I knew that I was taking my x, dividing by 2, and moving it pi over 4 to the left, I could write that here, set that equal to x. If I unwind it, make x dash the subject of the formula, that becomes my function. And so you can see that is exactly what I did here. I set the x dash. I thought about what was being done to it. So here it's reflected in the x-axis, which means it's negatived, and then translated by minus a 2 in the negative x direction, and I set that equal to x. If you make x dash the subject, that is what goes into the f of x. So that is what g of x is. Similarly here, I thought about what was happening. I took my original, moved it minus, I subtracted 2 from it, and then I negatived the entire thing when I reflected in the y-axis, and then I set that equal to x, like I did here on the right, and made x dash the subject, which then goes into the function. And from this point, we can do choice substitutions, right? Because remember, whatever I put in, whatever I call x, I could call x1, and it will substitute in wherever I see x. And so what I did was I said, or rather, I can rewrite that with sort of any variable. I could re-index it, as they say. So I could say that f of minus a minus 2 is equal to f of 2 minus a. And from that point, no, sorry, this is 80%. Let me zoom in a bit. And from that point, I can say, okay, well, let me say that a equals minus b. I could substitute that in, and then I would get f of b minus 2 equals f of 2 plus b. Well, then I could say, okay, let b equal x plus 2. Sub that in, I get f of x equals f of x plus 4, which is how I got that. Because I'm comfortable reindexing, I just went straight there with the x's and didn't get confused. But if you find that confusing, you can try a multiple reindexing, changing the variable letter each time so you kind of see how it's all threading through and it doesn't feel like the same x. But that was how I fed that through and got b, and I was very, very pleased with that. So I think that was the gettable but conceptual. I just hate the logic of 17 because my brain just doesn't work that way. And I had it and then I let it slip from my fingers. So that's another 18 out of 20. But yeah, nothing sort of too bad in that. I was pleased with that because I felt like there were a lot of questions in there that could have gone very wrong and didn't go very wrong. So I was pleased with that. I at least didn't make any sort of, I read all the questions well, right? And that was kind of conceptual, both of those. I can't believe I had the brain fart on the quadrilaterals, but is what it is. And it shows that, like, I mean, granted, like most of the time, like if you were being taught this, someone would have looked at the paper in advance and they would have done it, looked at the solutions, got it all together and sort of shown you how to do it. But that's not real. What's real is sight unseen, like you will be in the room. So I'd rather do it that way, get it imperfect and show you like, yeah, there's nothing wrong with you getting it wrong. We get it wrong the first time. And the first time you see it is the only time that counts. So I'm like, all right, let me just do it the same way you guys are doing it. So hopefully you found that useful. We just got a couple weeks to go. I will see you on the other side of Christmas. I'm going to pack in some streaming, certainly, because I'm on Christmas schedule. My workload's a little bit less. So I'm certainly going to pack in a bit of TMUA, a bit of the ESAT, Um, especially Sunday the 4th. So I'll keep posted, right? I'm always gonna like populate the streams in advance so you know what's coming and when, and I promise I will actually start at that time. So keep a lookout. And if I know my schedule in advance, I'll also post a community note so you can keep on top of when I'm going to post. So maybe you can mark it in advance if you want to show up live. If you can't show up live, totally fine. All of my streams populate on YouTube after the fact, and I timestamp for you to sort of go through it at your own pace. So hopefully you find that useful. If you have anything that you particularly want to go through, feel free to drop it in the comments of any of the videos. I check those and I try and go through those to make sure that gets covered. Comment here before we finish. You're in year 12. Should I stop preparing for the ESAT Oxbridge interviews from now? Not now necessarily, but certainly from the summer. So as soon as, because the way it works with like tutoring typically is I work on like 2 cycles a year, 2 6-month cycles. So we're coming up right up to the end of the admission cycle. So from the 6 months of July through to the end of December, that's admissions time. That's where you go through like your ESAT, your TMUA, your interview skills stuff. And then as soon as that finishes, then you set your mind to the summer cycle. So for you at this moment in your sort of university campaign, what you don't want to do is to prioritize your ESAT training, let your schoolwork slide a little bit, and do a little bit worse in your end of years. The reason why is your end of years are the predicted grades you're going to be applying to universities with. So those are the ones that are going to get you offers. So right now, your priority should be getting to the end of the year with complete mastery of the syllabus material. The reason why that matters is it kills 2 birds with 1 stone. First of all, it means you get the good grades to apply with. So you get your offers. Second of all, syllabus mastery is exactly how to do well in ESAT, because ESAT is fast. It expects you to know your syllabus stuff and to know it so effortlessly on lock, no doubt, that you can sprint and not get it wrong. So, and also at this stage in your sort of education, you won't have learned everything in the ESAT spec, but what you can do is keep your eyes on the prize, know what's coming, and prepare for it. So you don't necessarily know all the ESAT content, but you have to prepare yourself for the ESAT style, which is sprint. So what you can be doing at this stage is with your schoolwork, work on your speed, your consistency, and your accuracy so that you have less to take yourself, less of a gap to fill in by the time you get to the ESAT. So that's my top tip at this stage. It's not about preparing for ESAT yet. That can wait to the summer, but you've got to get yourself used to the ESAT technique, which is just fast, zippy. So in fact, in the summer, I'm going to carry on with this. Obviously, no one's going to want any work in the summer, but what I'm going to do is I'm going to do some speed runs, because I'm going to show people, typically in July is when I work with students on speed skills, which is where you basically go through an AS paper in math as fast as humanly possible. So we're talking like if the paper is 2 hours, see if you can get it done in 45 minutes, like that fast. And that's what you're prepping for. So it's less specific. It's more general skills based, making sure you understand. You don't just sort of look at the schoolwork and go, oh yeah, that makes sense. That's fine. It's like, whoa, does it really make sense? Do I understand it deeply? Is there any doubt? If something's going to break here, where is it going to break? And kind of make sure it is as strong as possible so that when a question comes your way, you're not going to break. And that's my advice. I have a lot of opinions on that, as you can tell. Right. So I think I'll leave it there. That's good today for the TMUA. Hopefully you find that useful. I will not be streaming again this week, but I will do something again, I think certainly next Monday. What are good resources for physics to refer to in order to make concepts as strong as you're suggesting? You do nothing but the textbook. Textbook's good enough. But just do every question and ask yourself, is my understanding here as strong as it can be? Ask questions until you're like, does that make sense though? So basically just try and get and one thing you can do is just make sure all your topic tests are as good as possible, right? So it's not the case of like, oh yeah, I'll get like a 75 on this one, but then I promise I'll revise in the summer. Like, that can't be the attitude. I think the attitude is, I'm going to get it now. I'm going to master it now. I refuse to move off from this topic until I completely understand it, such that I could get a pop quiz and get 90%. Like, learn well. Don't push yourself. It's about depth of learning as you're going. So as a new topic comes in, plant it as deeply as possible so that it's like, you don't need to revise your timetables. They're in there. And you kind of learn it that well, and then you'll be fine. So you really don't have to do too much. Textbook is fine, but plant the flag. So there you go. Right. I will see you guys next, I think, on Monday for another live stream. I'll do another live solve. It's likely to be an ESAT because I haven't done one of those in a while, and I want to make sure that's covered, and that's been specifically requested today. I'm also going to do, I think, on maybe more like a Friday, the 2nd, I'll probably go live in the evening going through, that'll be ESAT as well. I think I'll do like a theory session, just making sure all the basics are covered, maybe going through the spec, making sure everything is like kind of all right there, because I've had someone ask me to explain the different types of questions you get. And then from the week of the 5th, that's when we're into TMUA time. Maybe on Sunday the 4th, I'll go live, do, I think, in fact, on the 4th, I'll do a TMUA deep dive into like necessary and sufficient logic, all that kind of stuff, and maybe do a live solve on the 7th. So that's just sort of me planning in advance. Hopefully that works for everyone here. If not, you can catch up afterwards. And in the meantime, I'll leave it to you to, well, I was going to say work hard. Have a good Christmas. Then start working hard again when you're ready. And I will see you next Sunday, ready to keep it going again. No, next Monday, ready to keep it going again. All right. I'm going to stop filibustering. All right. Take care, guys. I'll see you next time. Bye-bye.